had to change it up from hi guys. So today we're going to talk about quadratics. This is chapter 4, lesson 1. And what you're seeing on your page, the first thing that you see is the parent function. Now if you go back and remember what a parent function is, they're the most basic form of the function. And remember, these functions can have families, so I can transform them or move them to the left or move them to the right or up or down. I can flatten them or stretch and compress. I can do all of these things to change a function. But if I don't touch it and it's in its most basic form, it's called the parent function. And so the quadratic parent function looks like f of x equals x squared. Okay? And the shape that it makes is this U shape. And the U shape is called a parabola. Now, it continues on forever and ever. As this continues, each side continues to go up. It keeps widening out as the x values are increasing or decreasing. Okay? It continues to get wider and wider, and it continues to keep going up. So we want to put arrows. Most graphing software that I use, it will not put an arrow on the end of it, but you need to understand that it does keep moving up and out. It keeps widening. Okay, so you can look at this function on either your graphing calculator or there's a website called Desmos, which I'm going to pull that up now. And what I want you to do is we're going to look at some very important points, and we're going to write them down in this table. So if you go to Google, and you just type in Desmos, D-E-S-M-O-S, and press enter, this Desmos beautiful free math is what comes up on my screen, and we start graphing. Just click start graphing. Now you'll put your function in here, so I'm going to type in f of x, f parentheses x parentheses equals, and you can go down here to get the squared part. You hit x, and then you can do that, and it'll make it squared. And this is the picture that you see of the graph on your notes page. Now, really and truly, there is one really important part or point on this graph, and that is this point right here, because that's where this function begins to change directions. So if you're reading it from the left, it's falling down, 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 and all of a sudden it gets here and it says, I'm going to go up, 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 up. Okay, so this point right here is called the vertex, and notice as I hover over it, it shows you the point. I'm pointing at my screen, and I know you can't see where I'm pointing, but it shows you the point 0, 0, okay? Using this software, you can go up to settings here, the settings wheel, press it, and then convert this function to a table, and there's information right there of where you would plot the points, and take a look here at all the points that it's plotted for you. Okay, so it's given you some specifics. So let's go back to our notes, and let's write some of these down. So I'm going to put the vertex in the center here of my table. This is the vertex, and that's this point right here. The vertex is either the highest or the lowest point that the graph ever reaches. Now, if you go back to your website, you'll notice that at -1 we're at 1, and at 1 we're also at 1. Now you can get this information by just plugging in the values. So if I have f of x equals x squared, and I want to try to figure out what happens at -1, I could say f at -1, and that, remember, that just means plug in -1 for x. So I'd say, well, -1 is my x value, and I want to square it. And what is -1 squared? It is 1. So when I plugged in -1 for x, I got +1 for y. And when you plot that point, -1 is approximately right there, and +1 is approximately right here. And so there's a point right there. If I wanted to find what happens at 1, I would do the same thing. So f at 1, go back to your original function. If I plug in 1 for x, I get 1 squared. And 1 squared is 1. Therefore, at 1, I am at 1, and I'm forming the parabola. Okay? At -2, if I plug in -2 for x, f at -2 equals -2 squared. Okay, -2 squared is 4. So at -2, I'll be at 4. There's a point right there. And at 2, 2 squared is 4. I'm also at 4. So there's something special that's happening here. When I find the vertex, and that's the lowest or the highest point, when I find the vertex and then I move to either the left or the right, there will be a point that is directly across from it. So see how there's these 2 points line up horizontally. These 2 points line up horizontally, which means I can fold this graph in half and it will line up. And I hope you know what that means. Hope you're thinking the word symmetrical, or it has some symmetry. And if you were thinking that, you're absolutely correct. If I drew a line right through the vertex here, I could fold each side of this parabola over and it would match perfectly. So these quadratics, any quadratic, is symmetrical. Now, what you want to do is you want to be able to find that axis of symmetry, that line right there that goes through it, and it'll always go through the vertex. You want to find that line to help you graph. So let's continue here. Here's standard form of a quadratic. It looks very familiar. Okay, ax squared now, because we're talking about squaring or quadratics, plus bx plus c, and the a value can't be 0. And let's talk about why. If I put a 0 in front here, that 0 would multiply by x squared and it would get rid of it, and therefore you would only have a linear function because this is only x to the first power. Okay, so you need the x squared value. To find the axis of symmetry, if you can identify the a, which is a coefficient there, the b, and the c, you can plug in your a and your b here and solve this, and it will tell you the line in which the parabola is symmetrical. Okay? All right. Before we go on, because I don't want to do too much talking and not enough problem solving, let's wait to do the vertex, but let's try to find the axis of symmetry in this example. All right? So we're going to use this formula. X equals the opposite of b. You can say negative b if you want to, but sometimes it's easier saying the opposite, because if the number is negative, you don't want to say a negative negative. So the opposite of b over 2 times a. Well, let's look at all of the coefficients. In front of this x squared, it's understood to be 1. So the a value is 1. The b is in front of the linear term, the x, so b is 2. And notice the sign is positive, so I can just say 2. The c is the constant term, it is -1. So now I'm going to plug in whatever I need for this here. The opposite of b, so the opposite of a +2 would in fact make it -2. over 2 times the a value is 1. Simplify, negative 2 over 2 is just negative 1. So there is an axis of symmetry, a line in which this function will be symmetrical that goes through negative 1. So I go over to my graph and I say, okay, where is x equal to negative 1? That's here. So there is a vertical line going through, and you mark it with like a dashed line. When you get used to graphing these, you don't have to put this line anymore. So here is a line in which my graph will be symmetrical. So I know I'm going to have a graph that goes through, the vertex will be somewhere on this line so that the rest of the graph can fold over. Okay? All right. Now let's go back here. The vertex. If we take that axis of symmetry, because we know that the vertex is on that line, if I plug that number back into my equation or my function, that will give me the y value. So here's a point, x comma y. So it will give me the y value if I plug in this value for my function. Okay, so down here, negative 1 is the axis of symmetry. That is the x value of the vertex. We don't know the y value yet, but I'm going to take and plug in negative 1 into the function here. So f at negative 1 equals negative 1 squared. Be very careful, you need to put it in parentheses, plus 2 times negative 1 minus 1. So f at negative 1 equals, this would be positive 1 minus a 2 minus 1. 1 minus 2 is negative 1. And negative 1 minus 1 is negative 2. So when I plugged in negative 1, I got negative 2 as my y value. So negative 2 goes here. And now you know the vertex. The vertex is at negative 1, negative 2. So I go over negative 1, down negative 2. There's the vertex. And I'm going to put it in the center of my table. Negative 1, negative 2. Now I need to pick points that are surrounding this vertex to see what happens on the left side of it and on the right side of it. So since that fell on negative 1, I'm going to look at negative 2 and at 0. So let's look at negative 2 and see what happens, and 0. Take negative 2 and plug it in. Negative 2 squared, and you can use your calculator for this if you'd like. F at negative 2, negative 2 squared, plus 2 times negative 2 minus 1. This would be 4 minus 4 minus 1. And so f at negative 2 equals 0 minus 1, negative 1. So at negative 2, I get negative 1. At negative 2, I get negative 1. Put a point there. Now, what should happen is I should have a point that is directly across my axis of symmetry. So I should have one right here. Okay? So at 0, when I plug in 0, f at 0 equals 0 squared plus 2 times 0 minus 1. F at 0 equals negative 1. And so therefore, when 0 is plugged in, I get negative 1. 0 on my x-axis, I get negative 1. And now you can see a parabola. Make sure that when you graph this, all you need is 3 points, but make sure when you graph this that you make a U shape and not a V shape. You could, if you did not understand that quadratics make a parabola and that is U, you could accidentally draw this as a V, and that would be absolute value, which is not correct for this one. So All right. Now, the other thing that you can do is instead of we're going to find the axis of symmetry and then we're going to find the vertex. But then we also can look at the y-intercept, okay? So first let's find the axis of symmetry. Opposite of b over 2a. Well, the a is 1. The b, careful, is negative 2. And the c is 4. So we take the opposite of the b value. Well, the b value is negative 2, so the opposite of negative 2 would be positive 2 over 2 times a, which is 1. So 2 over 2, which is just 1. So x equals 1. That is our axis of symmetry at x equals 1. This is the line that our parabola will be able to be folded over. So it's where our vertex is. Plug in x equals 1. Plug in 1 for this equation here. So 1 squared minus 2 times 1 plus 4. 1 squared is 1, minus 2 plus 4. Negative 1 plus 4 is 3. So the point for the vertex is the 1 from the axis of symmetry and the 3 from when you plugged it in. So 1, 3. So at 1 on the x-axis, 3 on the y-axis, again, your vertex is directly on that line. Now, something else that I want to teach you that makes your life a lot easier. If you look at the c value is your y-intercept. And if you remember, the y-intercept is where the graph crosses the y-axis. That means the x value is 0. You plug in 0 for x and get y, that's your y-intercept. Remember that. So at 0, 4, we have a point. So at 0, 4, we have a point. Now, because we know that these graphs are symmetrical, you can say, well, what is my distance between these 2 points? So I only went 1 step over. So if I go 1 step to the other side, I should be in line horizontally. Now let's check and see. If I plug in 2 here, I would get 2 squared minus 2 times 2 plus 4. 4 minus 4 plus 4. And we want to see what that equals. So y equals 0 plus 4, which is just 4. That was when I plugged in 2. So now we can connect, make a U shape. As long as you are not using straight lines, you're doing good. Okay, just a few more things. If you're given a graph, let's talk about the vertex, axis of symmetry, minimum, maximum, and domain and range. First of all, find the vertex. So here, the highest point. This is a vertex, and look at your x, y values. Look at that point. So the vertex here is 3, negative 3. Now, the axis of symmetry, remember it's the vertical line that goes straight through the vertex. So the axis of symmetry, some people put AOS, that's okay. The axis of symmetry is at x equals 3. You have to say x equals 3 because an axis, any axis is a line, and so this is the equation of a line. If you just say 3, you can't, that's not telling me anything because on a graph it's made up of a lot of different things. 3 doesn't even represent a point, so you can't just say 3. Now, look at this graph. Up, 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 highest point. That means we have a maximum because there is a highest, okay? So the maximum here is the highest point comes in right here. The y value is what you want to look at, or the y value of the vertex. That's the same thing. So it's just the y value. So the max is -3. You can tell me the max is -3. Just the number. That's fine. Now, domain. Domain talks about the x values. Okay? So we're going to look across this graph, and remember, this graph keeps going down, 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 and it's going to keep getting wider, 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 wider. All right? So the x values will keep spreading. Okay? I will be able to use every single one of them because this graph continues forever and ever, and it keeps widening out. So all of the x values, I can use every single one of them. So I'm going to say from -infinity, that's all the way on this side, all the way to +infinity, I can use any of those numbers. Okay, the range. Range is your y values. So look at where your graph starts. Notice it has arrows, so we went down, 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 down. Okay, so if you think about where did it start from the lowest point, well, there isn't a lowest point. -infinity is where it's coming from. It's coming from way down here, okay? And it's going up, 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 up. And this is the last part of my graph. That's the highest point. There's nothing at -2. There's nothing at -2.5. There's nothing in the positive range. So I have to tell my y values, if I'm talking about range, they stop at -3. Okay? So your minimum or your maximum will affect your range. Wherever your vertex is, that affects your range. Okay? Let's look at this one. Last one. Vertex. The vertex is at, the point is x comma y, 4 comma -1. Okay, now look at this, the axis of symmetry. The axis of symmetry is at x equals, it goes through this point, through the vertex, okay, and it's a line, x equals 4. Does this one have a minimum or a maximum? Hope you say minimum, because look, there's a lowest point. Low, minimum, lower, okay? Minimum. And the minimum value, remember, is the y value of the vertex, or you can just look at the lowest point here, and what y value is it? -1. Okay, domain. Again, your x values, as this graph continues to grow, x values go like this. You can go all the way down to the lowest x value, all the way to the highest x value, but your graph will keep going like this and widening and widening and widening. And so I can use every single x value. So it goes from -infinity to +infinity. And the range, remember, range is affected by the vertex. Okay, where is the starting point, the lowest point? Well, -1 is where my graph actually, it doesn't go lower than -1. So -1 is the lowest value on the y-axis that we'll see. And then it goes forever and ever up. It keeps going up, 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 up. Okay, so all values from -1 to infinity are used. All right, we will practice some of these problems. I'm sorry this video was long, but it was a lot of information. We'll practice some of these problems in class. I hope you have a wonderful day. See you later.